Though the color is not very good, but we would like to learn something about the polymers. Please keep quiet. If you have anything to say, please tell me. Then we can share everyone. Okay. Okay. Today we are going to learn about the polymers. In the first class, I have mentioned something regarding the polymers because we have discussed all the chapters what we want to learn about this, and then we have mentioned something regarding the wheels of plane and cars, and also what we wear and different types of sandals, shoes, whatever. Most of the things are made of different types of polymers. So we will learn how we can classify the polymers and what are the types of polymers, and based on different categories, based on source, or how we can synthesis, there are different classifications, and what are the components we can synthesis or we can prepare the polymers. So here you can see different types of things. Just maybe you are not familiar with this one. However, all the things, this is the car or car tire. There are many types of chemicals, and also these are the containers. These containers also made up of different types of polymers. So we'll learn one by one. First of all, we would like to know what is monomer. The word polymer comes from, or not word, I would say the compound. The compound polymer comes from a combination or addition of many small molecules. What we call that these small molecules are considered as monomer. Sometimes we call mers, not mono. You don't need to mention mono. Sometimes we call it mers, monomers. We write down polymers by combination or addition of lot of monomers. That's a small unit. So here you can see that this is a small unit. So this small unit, when combines with many other small units, then we can have a very long chain or very long molecule. So we can have this as the polymer, and this is the monomer. Here you can see ethylene, just C2H2, sorry, C2H2 or C2H4, ethylene, C2H4, is it? Okay. So C2H2, C2H4, and then we can have polyethylene, what we use very often, polyethylene or plastic. Okay. So even the water bottle, that one, that one also a kind of polymer. Even the water, inside the water and the cap are different types of polymers. So we will learn, here you can see vinyl chloride and polyvinyl chloride. So this is a monomer, and if we combine or if we add many of the monomers, then we can have polymer. Different types of, just we are using vinyl chloride. Now add one word, just polyvinyl chloride. Then you will get PVC. All of you are familiar with the PVC. So maybe we do know how to have any door, PVC door, or whatever. Maybe I can guess this board. Maybe not. Just any hard plastic. Most of the time, any hard plastic we can consider that as a PVC. Okay. So monomers combine each other in large rise in, sorry, what? Right, yeah. Okay, monomers combine each other in large numbers to give rise to a polymer. Just as we have mentioned that we have many monomers that combine together to give a very large molecule that is considered as polymer. Okay, we can move forward And you can see one animation here. Here you can see we have very small unit, the red dot. This is our red dot. This is one small unit. If you have something like this, hundreds or millions of small unit, and then it is combining one another. So this is very long chain, so that we can consider this is our polymer and that is our monomer. And that would be the repeating unit. This is one, this is another. All of them are just similar or same unit like this one, and they are combining or joining together. Polymers, poly means many. Everyone is familiar with the word. So polymers are the high molecular weight compounds. Why high molecular weight? Because if we consider that this is very small molecule, and if you consider it has the molecular weight 100, then if there are 10 units, then the molecular weight of this polymer would be 1000. Is it? So the polymers, most of the case, in the polymer we have few thousands to 1 million units of the molecule. So this unit can have around 1 million. 1 million means 10 to the power 6. 10 to the power 6. This unit or this number of monomers can be in a one polymer. So if you have that number or that much number of units, one, two, three, four, five, six. Okay, that is the this 10,000. Sorry, 1 million multiplied by 100. What will be the molecular weight for this polymer? If we consider this is 1 million units, then 100 millions. 100 millions is the molecular weight of their polymer. If we consider that 1 millions of molecules are combining to make a polymer, in that case the molecular weight of that polymer would be 100 millions. So polymers are the high molecular weight compounds. So the molecule would be with very high molecular weight. Then that has never used. So we can have different types of, this is here you can see ethylene, C2H4. So this is one unit, this is another unit, this is another unit, this is another unit. So here we are having 4 units of ethylene. And when it is combining to form, just you have double bonds. Here carbon-carbon double bond, carbon-carbon double bond, carbon double bond, double bond. So if you have this carbon can make bond with the nearby carbon. So with another unit, if this carbon can form bond with another unit, so if you can break one of the bond, this carbon-carbon double bond, then this carbon can have 2 valencies. If you can break one double bond, is it? In that case, it will have one valency with this, and this will have another valency with this. So in that case, this one unit can combine with 2 other units. So here is one unit, another unit. So they are making bond. This carbon is making bond with this, and this carbon already we have. So by this way, it is making very long chain. Same thing, same animation. Degree of polymerization. What does it mean? The number of repeating units. That means how many or total, how many molecules or repeating units will be in the polymer. So how many molecules are combining to make a polymer? That is the degree of polymerization. As already I have mentioned that 1 million of molecules. That means if a molecule have 1 million of monomers or repeating unit, then we can consider the degree of polymerization of that molecule would be 1 million. So, sorry. আমি বিজি আছি হ্যাঁ আমি বিজি আছি সন্ধ্যার পরে 8টার পরে কল করব ওকে degree of polymerization, what I have told that how many molecules or the number of repeating units in the chain of which polymer is made up is called degree of polymerization. Polymers with high degree of polymerization are called the high polymer. This is very simple thing. That means if you have lot of molecules or relatively lower number of molecules, then you will say that this is a polymer with low degree of polymerization are called oligopolymers. Actually, the high polymer and oligopolymer, that means if you have very small amount or very small number of molecules, in that case you can consider this is oligopolymer, and if you have lot of molecules or lot of repeating units, then you can call high polymer. High polymers have the very high molecular mass, 10,000 to 1 million atomic unit, are called the macromolecules. Macromolecules, something or a molecule which is very large. Macro, not micro. You are familiar with the micro and macro? Yeah. And also maybe you are familiar with the nano scheme. Most of you have the mobile phone and all of you are using the nano scheme. Actually, this is not the nano size, because nano size you cannot see with your eye. But actually, what we are using in the latest version of the mobile, they uses very small chip, so that we consider first generation, second generation, third generation. The third generation, what we are using, these types of SIM, they are very small compared to the previous one. Therefore, we are calling this is nano SIM, but not in reality. Common polyolefins. Let's see some of the monomers which can form the repeating unit and which can make the polymers. Sorry. Ethylene, polyethylene, we can form polyethylene. This is the repeating unit. Here you can see this is the C2H4, that would be the repeating unit, and one side, another side. So up to this way, this part or this part, just continually it is repeating. And if you change this part and this part, depending on what are the part or what are the additional substituent we are using, the characteristics of the polymer will be changed. Later we will discuss what types of polymer or what we ought to prepare or something like this. This is propylene. Propylene, that means unit containing or hydrocarbon alkene containing 3 carbon atoms. Is it? This is the propylene. So just yes.
How do you know that this many is 1 unit?
Okay, this is the 1 unit. How we can consider? Is it? Okay. That is very simple, because when we take the different types of UV visible spectrum, or if we take the another instrument we had, but we can calculate the molecular mass. We can calculate the molecular mass, but everywhere, whatever, all the repeating units have the same characteristics. Whatever, if you have the molecule very large, but it shows the characteristics, every part of the molecule is same thing, same characteristics.
Yeah, I got that, because it's the same molecule.
Yeah.
Right? So what I'm thinking, degree of
polymerization.
How are we going to find that?
Okay. if you know the repeating unit.
So how should we consider that this is 1 unit and that?
Okay, in that case, just if you consider maybe this is 1 unit, this is another unit, so or whatever we are getting, when you have this type of CH3 double bond CH and CH2, in this case, you will have the repeating unit. What? Maybe I can write down. You should have these types. So this is CH3, this, and then this is C. Here was double bond and C. So this is your one repeating unit. This is another repeating unit, like this. So if you have always you are getting the repeating part. That means just
Monomer is the only one.
yes, monomer. Yeah, everywhere in the molecule you will have the monomers, all the monomers, and if you know the total molecular weight of the polymer, then you can have the the monomer, the molecular weight of the polymer, then you can divide with the molecular mass, so you can get the degree of polymerization. How many molecules or how many repeating units are there in the polymer? Okay. Okay. Polystyrene. So styrene is the monomer unit. This is our styrene. This is phenyl. Phenyl, and this is just double bond. So phenyl, or this is our styrene. So if you have millions or multiple styrene, then we can consider that as polystyrene. Okay. Vinyl chloride, then we will have the polyvinyl chloride, which I call PVC. Tetrafluoroethylene, polytetrafluoroethylene, Teflon. Maybe some of you are using the Teflon. So this Teflon can be just prepared by the tetrafluoroethylene. So if you have repeating units or a polymer made of Teflon, made of tetrafluoroethylene, then you can consider or you can call them as Teflon or polytetra PTFE, maybe you call it polytetrafluoroethylene. Polymerization. What is polymerization? The process of making polymer. That is called polymerization. A process by which linking bonding of two or more monomers of same or different type. Okay, that is another thing. Till now, we have mentioned that we are making the polymer out of same repeating unit. But sometimes we can have two different types of or several types of repeating unit also. In that case, we will get different types of polymers, but later we will see. But the polymerization is the process to make a polymer from monomer units. Okay. Degree of polymerization already mentioned that how many molecules are combined to form the polymer. That is the degree of polymerization. Just very simple things. Repeating again, oligopolymers, just low molecular weight, or if you have very low number of monomer units in the polymer, then we can consider oligopolymers. And if you have many number of repeating units, then we can consider high polymer. Or the process of making the high polymer is high polymerization, and the making of low degree of polymerization. So these types of polymer or oligopolymers, this is oligopolymerization or low degree of polymerization. Already, yes, sure. Okay. All of them already taught. Nomenclature. There are Homo polymers. That means if all the repeating units are same, then we call it Homo polymers. And if the repeating unit are not same, it can be 2 or 3 different types, then we can consider that copolymers. So the polymer obtained by repeated combination of only one type of monomer are called Homo Polymers. Just if you can understand the meaning of the word, then you can define. That is very simple. The polymer obtained by repeated combination of 2, or here you can see in this figure, all the repeating units are of same pattern. That means this is maybe consider this is CH2, this is CH2, this is CH2, CH2. All of them are same. So these are the repeating unit. So if you have the repeating unit same, in that case, what is my duster? Oh. So all the repeating units are same. So we are getting the Homo Polymers. And if you have, here you can see, this is black, this is another one. So here you have another pattern. That means one black, one white, two black, two white, one black, one white, and then one black, two black, one white, like this. So that means the repeating units are not same, or the properties. Even this can be one molecule, this can be another molecule. These are, so these and these are same, or these are same. So here you can see this is a polymer, but not the repeating units are same. Therefore, we can consider that as copolymer. Functionality of polymers. That means in previous slides I have shown you the polyvinyl chloride, vinyl chloride. Here you can see this is one chlorine here, and this is polypropylene or propylene. This is our monomer. So here we had a double bond, here we had a double bond, and this is CH3. So the functional group, we had a double bond, and here we had a double bond in addition to halogen, chlorine. Chlorine, this is part of halogen. We can consider anything, chlorine, bromine, chlorine, whatever. So just I'm mentioning that like as a halogen. So what types of functional group you have at the polymer, that or that should come from the monomer? Is it? All the monomer should be same, and the repeating unit in the polymer would be just combination of the monomers. So what types of functional group you have in the polymer? That is the functionality of the. So the functionality of a monomer molecule is the number of functional groups. What types of functional groups we can have in the monomer? Groups, reactive sites, bonding site, which participate in the polymerization. Therefore, the number of reactive sites in the monomer is referred to as its functionality. So, if we consider for alcohol or carboxylic acid or any other thing, we can have different types of functional groups, and it can have the reaction. If we consider for carboxylic acid, in that case, we can have the carboxylic acid can have the reaction in terms of COOH. That means it can react due to having hydrogen, or it can make the ester, or different types of functional group, or it can have the reaction due to having the OH group. So it can have the different types of functionality. So the functionality of a monomer molecule is the number of functional groups. How many functional groups can have in the monomer unit? So groups or reactive sites or bonding site which participate in the polymerization. Therefore, the number of reactive sites, maybe here you can see the linear chain polymer is formed by the, if the functionality of the monomer is only 2 bifunctional. That means if you have these types of monomer, this is one monomer, this is one monomer. So if it can form just bifunctional, this can have, if one side is completely closed. In that case, it cannot have or it cannot form the polymer. So it should have the bifunctionality. That means the repeating unit should have the possibility or probability to create the two-side bond so that they can combine with two different molecules in the two sides. So, sure, the monomer unit should have the characteristics so that it can make bond to the adjacent units. Here we can have these types of here we have another types of. This is one of the functional group, but it cannot be the. It cannot combine. It cannot combine with this. So this unit, and this would be completely repeating. Just this cannot form bond with another one. What I have mentioned there, if we do not have the ability or if we do not have the characteristics so that it can have the valency or it can have the bond, in that case, just if the repeating unit has the possibility or ability, not possibility, I should just say the ability, because possibility that means it can be or not. But if we say ability, that means the unit should be able to have the valency 2 so that it can combine with two adjacent sites or two adjacent atoms. So, but here it do not have. So it is just this is our repeating unit. So it can have the bond with the nearby or adjacent two atoms. So they can be the repeating unit, and if it is combined with this, then we can consider this is a repeating unit. But by itself, it is not a repeating unit. When it comes with the this part, whole part, in that case, it can be a repeating unit. Okay. Here is one information: tacticity. Tacticity. This is very interesting term. The orientation of monomeric units in a macromolecule can take an orderly or disorderly fashion with respect to the chain. The difference in configuration is called tactility. Okay. What type of orientation? If the orientation of what? Orientation of monomeric units. This can be our macromolecule or the polymer. We can consider if the polymer has a very high molecular weight, we can consider that as a macromolecule. So the orientation of the monomeric units in a macromolecule can take place in orderly or disorderly. That means it can have very proper orientation or sometimes it can have different orientation. So the difference in configuration is called what types of orientation you have. That is called that is orderly fashion with respect to the chain. Yes. Then that is tacticity. The orientation of the monomeric units compared to the chain, that is called as tacticity. And if you have the isotactic, that means the word isotactic, that means similar orientation. So if all the side functional groups lie on the same side of the chain, it is called as isotactic polymer. That means till now, whatever we have learned today, all the things just comes with the word. Just if you can understand the meaning of the word, then you can define all the what is this. So isotactic polymer, that means same thing. If the functional groups are in the same side, then we can consider that is isotactic. And this if the arrangement of the side groups is in alternating fashion in different way, that means not in the same side. In that case, we can consider as syndotactic and atactic polymer. If the monomers have entered the chain in a random fashion, that means if the monomers do not follow any pattern, that means sometimes we can have the functional groups in the one side, then we can call it isotactic. In some that means one side up, one side down, one up, like this way. In that case, we can call it syndotactic. And if there is no pattern, randomly, one here, another here, so what, like this. So in that case, we can atactic polymer. There are some examples. You can see what types of functional group we can have. This is the methyl group. All the methyl groups are in the same side. Therefore, we can consider that as isotactic. These methyl groups are on opposite sides. Just by this way. So, syndotactic, and just one is here, here is these two, and then there is two. So randomly there is no specific pattern, so that we can consider as atactic polymer. Okay, now that are also very similar thing. You are familiar with the word, the natural polymer and synthetic polymer. So something what is grown naturally. Sorry?
See, I was saying that the rubber tree.
Yeah. Rubber tree is the natural polymer. Okay. So the polymer what we get by naturally, that is called as natural polymer. And just example, you mentioned the rubber, what we get from rubber tree, and the synthetic polymer. So if you can synthesize the polymer in your laboratory or in any industry artificially, then we call it synthetic polymer. Yeah, definitely. These are the polymers of the natural origin, such as plants and animals. Example: silk, wool, natural rubber, protein, starch, cellulose. But do not try to memorize this formula. You don't need. Yeah, that is impossible, is it? But not exactly, because if you can remember only one unit, then that's fine. Just one unit will be fine. So what is this? How many carbons you have? You don't need to memorize. However, 1, 2, 3, 4, 5, 6. This is oxygen. This is oxygen, is it? So 1, 2, 3, 4, 5. This is 6. This is another carbon. So this is a 6 member. That means ring of 5 member, and then that's like a something glucose, a structure like this, is it? So something like this. So that is not so difficult. Okay? That is not impossible. Possible. Yeah. Okay. Today it seems the class is very easy, is it? So you are enjoying. Okay. Now here you can see. Oh, this is too dark. This guy is making something inside the laboratory. Like that. This or this. Okay. That is also a kind of a painting, you can say. Painting, and also sometimes you can make different types of I think in my country I have never seen something, the road made of polymers, but some of the there are many roads, and especially in the park. In the park you can see some roads made of different types of polymers, and the kids can jump over there, and very soft and very comfortable to walk over the rubber. That can be different types of. So I cannot see what he is doing. This is the no, yeah, making some compound, that means making some polymer. So I can see in my display, this is quite good, but you cannot see. Maybe should I rotate? Yeah, today it is not so difficult to rotate my computer. Can you see something? They are making?
She's giving time to
Okay, so some person or someone is working in the laboratory to synthesis some polymer. Just we are showing like this, right? That is same thing. This is a conical flask. Is it a conical flask and something? This is in the beaker. So some chemicals they are synthesizing. This is a laboratory, so they are making something. Excuse me, if you have something to tell, please ask me or share with all of us. You have something to tell? Huh? Okay. Classification based on methods of synthesis. Just previous classification was based on the source, where we can get the polymer. If we can get the polymer in nature, then we can call it natural polymer. And if we can synthesis in the laboratory, then we can call it synthetic rubber or synthetic polymer. But if you can synthesis the polymers in different way, that means definitely in the laboratory, what we consider for synthetic polymers. Addition polymer, that means if you have some polymer that can be prepared by the addition reactions. Addition reaction, that means just what are the repeating units? They will make a single bond in between the repeating units. So just the addition polymers are formed by the repeated addition of monomer molecules processing double or triple bonds. It can be. So here you can see this is the double bond. So this repeating unit is forming a single bond. So it will have just join. There is no anything else, but sometime you can have the reaction like a condensation. Are you familiar with the condensation reaction? What happens in the condensation reaction? Condensation. Do you know the condensed milk? Condensed milk. What is this? Condensed milk. Higher density. Okay, that can be in one sense, and another sense we can say that more water has been removed from the milk. Is it? Condensation means just something removing one molecule. Maybe if we consider that how you can prepare the water, sorry, ester. How you can prepare ester? Yeah, esterification reaction. That means esterification reaction comes out from carboxylic acid and alcohol. Then what happens in the esterification? This is CH3COOH plus HO, then CH2CH3. This is carboxylic acid, this is alcohol, is it? Then what happens? Like this. It's just minus water. Removing one molecule of water And then what happened? You are getting, just remove this part, then you will get CH3CO, then another O, then C2H5. Then C2H5. That is your ester. So how it formed? By removing one molecule of water, is it? So the amount of water has been decreased. So the density increased. It's like as condensed milk, what I am saying, that in terms of condensed milk, the pure milk is boiled out for a long time just to remove most of the water. So remaining the water, sorry, the amount of water remaining is very less. Therefore, we can call it condensed milk. So this is condensed compound from carboxylic acid and alcohol. So in next slide, we will see that we can prepare the polymer in the process, in a process like as condensation. So this is addition. So addition polymerization, you already understand that just if the repeating units combine one each other, that means just by joining, then we can have the addition polymer. So next slide, condensation polymer. Already what I have told you that the condensation polymers are formed by repeated condensation reaction between two different bifunctional or trifunctional monomeric units. So in this polymerization reaction, the elimination of small molecules. I have shown that elimination of water molecule. You can have the elimination of different types of molecules like as HCl or any other thing. So anything. Just I have shown the removal of water, but we can have different types of removal or elimination. The condensation polymers are formed by repeated condensation reaction between two different bifunctional or trifunctional monomeric units. In these polymerization reactions, the elimination of a small molecules such as water, alcohol, hydrogen chloride, etc. takes place. So you can have different types of small molecule that can be removed to get the polymer, so that we can consider that as condensation polymerization. For example, nylon 6,6. You are familiar with the term, I think. Yeah, nylon 6,6 is formed by the condensation of hexamethylene diamine with adipic acid. So this is any problem? Okay. So nylon 6,6, this is a compound. So this compound can be generated or can be synthesized by the condensation reactions of this hexamethylene diamine with adipic acid. This is our adipic acid. So that means if you actually it happens by removing a small water molecules. That means here we can see that plus H2O, n molecules of H2O. That means this comes from by removing water from this. Is it? From these two molecules, we are removing few molecules or a lot of number of molecules of water. So the density of the molecules is increasing. Therefore, by removal of water. So that is an example for the condensation. Okay, and then thermoplastic and thermosetting plastic. That is even easier. Thermoplastic and thermosetting plastic. Okay, so you have seen all of you the PVC pipe or the plastic chair. Is it? Do you think that if you one leg of the one chair is broken and then you can melt it and you can prepare the chair again? That is possible or not? No, that cannot be. Yeah, pipe. Yeah, pipe. But if you melt it, Okay, some of the pipes, but even that water container, that can be maybe better we consider just normal polythene bag or plastic. Maybe this one. If you heat this, then it will melt, and then you can reform into different shape. Okay, that means this is not very hard, is it? Just if you heat with very low temperature, low temperature, that means around it should be more than the room temperature. So maybe around 100 degrees Celsius is quite good enough for this. So if you heat up, then it will melt and you can reform into different shape. That means the molecules of this are not rigidly combined each other. Therefore, you can easily remodel by heating or cooling. So, but there are some molecules which have very rigid structure. Once they are fixed, if you heat up, then it will completely decompose or broken up. So you cannot remodel it. So based on these characteristics, we can classify the plastics into two different categories: thermoplastic and thermosetting plastic. Thermoplastic, what you can remodel in with increasing or decreasing the temperature, and thermosetting, that is fixed. You cannot remodel it.
What about the recycling? What do we do with
Thermosetting plastic, most of the time they are completely decomposed into other chemicals. So in that case, maybe we can use to make the sometimes we can, oh, one very interesting thing, using these types of plastics we can prepare diesel, you know, diesel, kerosene, using these plastics. Yeah, the car diesel or kerosene, just fuel. Using these types of plastics. You do not believe? I can show you. It is not possible. This is made of hydrocarbon, is it? That means very long chain hydrocarbon. So repeating unit. So this is a polymer. That means if you can boil up or melt this, and just you can burn it completely. You can burn it, and then what you can get, just even better to use very high pressure and then high temperature. And no, it will not go away. You need to capture the compound what we are preparing by burning. If you heat up, this is plastic, or that means this is hydrocarbon. That means something like this. What we have CH2, this is polymer. This is our polymer, is it? Yeah. That is polythene. What we have learned, polyethylene. Just we have many molecules. Yeah. Okay. Repeating unit is this. And then next another one. So if you use the pyrolysis process, that means pyrolysis or cracking. What is mean cracking? Decomposition of hydrocarbons, is it? So if you have, that means C10H22, this types of molecule, if you have, and then just heat up, then what you will get? Some smaller units, just maybe like this, C4H10 plus C3 H6 plus something, 4, 3, 7, C3H8 plus something like this. Maybe no, if it is not balanced, 22, 10, 6. It doesn't matter how many hydrogens I have given. Just I'm going to show you how many carbons we are getting, and then one of the products should be like this hydrogen. Just we are getting different types of fragments. That is what I'm going to show you. So if you have very big molecule and if you heat up with high temperature, then you can get. So if this is in solid or in liquid, in that case, if you heat up with very high temperature, in that case you will get the gas. Is it like us? Then if you can condense, these gases, this how you can condense the gas? Yeah, condensation. That means you are familiar with the water jacket. Water jacket. So just maybe this is a gas. You are generating that gas from somewhere, and then I'm going the water jacket. So this gas is coming in this way, is it? Let us consider. So here you have sorry. What is this? Okay, just let me draw and then I'll discuss. Water jacket. That means I'm giving this gas. So I'm passing water, cold water. This is my line connecting. So I have, maybe you can put my jacket over this line, is it? And then flow some water through this. You should flow water from bottom, and then it will cool up this pipe. Is it? That is possible? Sorry? Yeah, reducing temperature. So we are making this gas, and then you can cooling the process, cooling the gas. So here you can collect it by drop in a container. You can take it.
My point is,
Yes.
like we literally burn the paper right in the environment, so those plastic is going as a gas in the air or micro.
Yeah, because the environment, you are not taking the gas. If you can burn the gas in a container so that you can collect, is it? So by this process, you can collect the gas and you can recool it.
So that's how we reduce the
Pollution, yeah, that is possible. Yeah. So thermoplastic and thermosetting plastic, just if you can remodel the let's see, polymers which can be softened on heating and hardened on cooling. Oh, sorry, yes. Excuse me. Today you are having a lot of chats. Why? Okay, the polymers which can be softened on heating and hardened on cooling reversibly without chemical change are called thermoplastics. That means just if you change the temperature very often or several times you can do it. But yes.
So basically, these thermoplastic and thermosetting plastics based on the molecular forces, right?
Yeah, molecular structure. Structure of the molecules.
So it was written in the other slide, it is based on molecular forces. So see, classification based on molecular forces, right?
Yeah, molecular forces.
So it has something to do with the forces. Like the thermoplastic will be having less molecular forces compared to the thermosetting.
Exactly. Because in case of Sp3 hybridization, if you consider Sp3 hybridization, you are familiar with this? That means one carbon is attached with other 4 carbons, that means or 4 atoms like this. Like this, is it? So this is, maybe we can consider like this, or hydrogen. So that means this structure is very rigid and very, in case of diamond have similar structure like this. Therefore, the diamond has very strong attraction force between the molecules or the atoms in between, I could say. Therefore, that is very brittle. You cannot, normally you cannot melt it or you cannot break it easily. But graphite, it has the structure something like this, is it? Just layer. If you want to write down with your pencil, just in every time you are writing on the paper, that means you are putting some of your graphite on the paper so that it is making the line. Therefore, but with diamond, if you want to write down on a paper, what will happen?
You can write on a wall.
You can write down on a wall?
I mean, we can.
No, you can write down in the wall. That will happen. What will? Just like this is.
Yeah,
you can crack. Just you can make or you can cut. You can cut with the graphite. Either even these types of hard board or even glass also. Most addition polymers are the thermoplastics because it's very easy and the attraction force between the addition polymers is quite less. Therefore, it can be remodeled with heating or cooling. Typically, linear polymers with minor branched structure and flexible chains are thermoplastics. So just flexible. So if you heat, then the structure will be little bit loose, and if you cool, the structure or the attraction force will increase little bit. However, it is not very hard. So, or the attraction force is not too high. Therefore, it can be remodeled with heating and cooling. Now, you can easily understand what is thermosetting plastic. Just very hard. The polymer chain are held together by weak attractions. What is this? Same thing. This is thermoset plastic. That means in this you can see heated, softens, cool, and permanently hard. So you cannot go reverse way. That means if you want to cool it, here heated, softens, cool, and permanently hard. So it has the attraction force or the structure of the molecule is rigid and it's very fixed. Therefore, if you heat up first time when you want to remodel or you want to make the polymer, in that case, it's possible once you can shape it, reshape it, and then once it is fixed, then you cannot do anything out of this. Thermosetting plastics are the polymers which undergo permanent change on heating, irreversible. That means you cannot go back. Because on heating, thermoset plastics becomes cross-linked. Here you can see, if this is cross-linked, that means once this is in linearly, and then first we heat, and that means heated, softens, and then cool. When it is cool, then you will get these types of cross-link, these types of bond. So if you want to again melt it, what will happen? You need to melt, that means you need to break these bonds. Is it? Therefore, if it breaks the bond, that decomposes all the molecules. So that is not possible to break these types of cross-link.
We try to break the bond completely because it won't go back.
Yes, exactly. Once formed, thermoset plastics cannot be remodeled and they cannot be recycled. Is it?
Yeah.
Cannot be remodeled and they cannot be recycled. Even you cannot do recycle with this. So in that case, maybe we can use to make you can burn it to make some gases or some other fuels that can be prepared by condensation polymerization. That means for addition polymerization, what we have mentioned, in case of here addition polymerization, in that case that should be linear structure, and easily we can remodel it by heating or cooling. But if you have the condensation polymerization, that means maybe here we can have we are removing two atoms from from here, another from here. So they are making a bond between these when they are removing two hydrogen atoms or two different atoms from these two carbons. Therefore, in that case, it is making a condensation polymer or cross link so that it cannot be remodeled further. Thermoplastic versus thermoset plastics. Some examples or characteristics. Thermoplastics, little cross linking, just very most of the time we would say very little or no cross linking, most of the time just addition. And large cross linking, that means the cross linking is percentage of cross linking is very high, therefore it's very brittle and hard. This is ductile, soft, then hard and brittle. Soften with heating, do not soften with heating. Polyethylene example, some examples are polyethylene, polypropylene, just all of them are addition polymerization. And then vulcanized rubber, epoxides, polyester resin, phenolic resin. So these types of, just if you heat up, then you cannot soften it and you cannot reuse it. Compounding, oh, well, when we should end up 6:30. Okay, maybe just compounding of plastics. Compounding is a process of blending plastics with other additives. This process changes the physical, thermal, electrical, or aesthetic characteristics of the plastic. The final product is called compound of plastic or composite. One thing, it looks some chocolate. Is it candy? Looks like some candy, but I think this is not a candies. I have found some food in Korea like this. Sorry? Yeah, colorful different types of foods. Okay, maybe today I'm not going to teach you anymore. So thank you very much. If you have any question, then